Any questions here? So this is how the tangent line looks like. And then if you want to estimate what is this here, at x equals -2, you can do that. So the idea is f prime at A is the slope of the tangent line. That's what you have to know the concept. And of course, you can always do the graph like this, and you can estimate. Okay. By the way, okay, this is what you type it in case you didn't. Again, let me just tell you what you type in. F(x) equals a function, any kind of function here, and m equals this. M is actually the slope connecting the 2 points at x equals A and x equals A plus h. And then in this case, I let h be 0.001. That means the 2 points are very close by. And A, you can actually you can click this, and the point is actually moving back and forth. Oops, yeah, like this. So that's like a tangent line. Okay, tangent line right there. So that's the tangent line. So let me now let me erase, annotate, and then let me not erase. I'm going to save this, and then I'm going to erase this. And then now what I'm going to do is I'm going to introduce one more concept here, since I'm on the graph here. So let me just do that. And that will be this right here. I'm going to add one more line, and then the line is this line. This is the line. And then number 7, that's actually the tangent line, basically. And then I'm going to pick number 8. You know what this number 8 is? Oh, it's the green line now. The green line. So now let me make it go back and forth. What is this green line? Now this green line is a line which is perpendicular to the tangent line at that point of the curve. Now this blue line is the tangent line. The green line is called the normal line. Normal line. Once again, I do mention this in our notes as well. I think I do mention this in section 2.3. It's coming up. So again, the blue line is called the tangent line to the curve at that point, and then the green line is called the normal line. By the way, when the tangent line is a horizontal line, what does the normal line become? Line like this. When the tangent line is a horizontal line, what kind of a line is a normal line? Do you see?
Which one is normal?
When the tangent line becomes a horizontal line, then the normal line at that point will be what? Will be a vertical line. The vertical line, the tangent line, the normal line are always perpendicular. The definition of a normal line is basically the line which is perpendicular to the tangent line at that point on the curve. So this is how it goes. And the normal line is very important too. So if you take mechanics, then let's say this is like a roller coaster. If you think that this is like a roller coaster, then what? The roller coaster, then the friction is proportional to the normal force. So we have to know what the normal line is when you get there. So this is like a roller coaster, and the friction is related to the normal force. But anyway, cannot get into too much of that. That is something you learn when you take mechanics. I think the first course in physics. If you those of you who are going to take physics, if you're a math major or a physics major or something something that or astronomy major, of course, something, because astronomy is basically physics, and so then you have to you'll get into all these kind of things. Okay? I can also change the curve immediately. The advantage of typing in all this is because you know what, you have to just immediately change the curve. So in this case, I can curve what is one of the curves is actually x over and then x squared plus 1. Can I do that? Yes, x squared plus 1. This is actually a problem on 1. This is actually a problem on section 2.3. So let me, since I'm on the graph here, while I do this, and the graph, this kind of looks like this. Oops, let me magnify this. Oops, sorry. Let me just magnify this much here. Then we have this. So what is this here? Yeah, this, and then let me click. Where's the A? Where's the pointer? I see the pointer way over there. I see. So we click this. There you go. I see. The pointer is over here now. So this is the tangent line, and this is the normal line. And once you type in this much on the left side, all you have to do is change the function, and then you can actually get the tangent line to any graph. Again, on this graph, I made the h equal to 0.001. So with a naked eye, you cannot figure out whether that's 1 point or 2 points. It's actually 2 points. So you know what? If I magnify this part right here, if I magnify this part, you get 2 points. You know what? I can mark it right here. Number 6 is the other point. Actually, you know what? The green, the black point and the red point, they look like they're coinciding, right? But if I magnify this, you know what? This is actually what you see. Now you begin to see the 2 points. See? So it's kind of, you know what? Look at this here. It's actually, this is the curve. See this? The blue is the curve, and then the black is the tangent line, and the green is the normal line. But this blue line is that is the tangent line. Where's the tangent line? The tangent line, the blue line is the tangent line. Wait, what's the curve? The curve is a red line, I see. The tangent line is the blue line. Oh, you know what? The curve is actually red line, and the tangent line is the blue line. So they kind of coincide, because I magnified this almost infinite times. And the tangent line is really not the tangent line. It's actually the secant line, you know, which passes the 2 points here. Now you can see the 2 points. That's why if I go back here like this again, you know, it doesn't look like that's 2 points, and the curve looks like this. This kind of looks like a tangent line. Therefore, all the number you see right here is an estimate. Does that make sense? But, you know, that's close enough. Then you actually just look at the rough sketch, that is close enough. Oh, by the way, this number 8 equation. Now, this number 7 is a tangent line. The slope is m. And number 8 is like this. And when you say, I basically plug in this number 8 in standard form. And so that I don't want to put this 1 over m. If you put 1 over m, then it could be undefined when it becomes a vertical line. But here I put like this. Anyway, you know what? This is the curve. Any questions here? Any question about the curves or the tangent or anything of this sort? Okay, I'm going to go back now. Let me go back to the file, and this is what it was. Now let's look at this. Okay, now this is now the second page, section 2.2. Section 2.2, and then this is the second page here. And now we get into what we call the right derivative, and the left derivative, and all this. Okay, so let's look at this. Everybody with me here?
Yes.
Everybody with me? Okay, everybody. Okay, so now we are at the second page of section 2.2. The file number is 0722.pdf, and then this is the second page. And second page, we now get into what we call the right derivative of f. So we also talk about the left derivative of f. Also, we talk about the left tangent and the right tangent, and so on. And we of course, we talk about the left limit and the right limit. So now the question is, what is f prime minus or plus at x? This right here is the expression we see right here. This expression right here. This is what we call the right derivative. Well, you know, do you see the plus sign there? The plus sign may not be that clear, but the plus sign is actually right here. This should be a subscript is a plus sign. Okay, it's kind of hard to see. It's a plus here, and then this is a minus here. So definition, the first definition A, the first definition is f prime plus at x. So what is f prime plus at x? Now in this case, the fixed point is x. X is the fixed point, and now pick the point t. Now if you look at this definition here, this is almost the same as the definition of the derivative. Now, what is the only difference? What is the difference? What is the definition of f prime plus at x? This is what we call the right derivative of f at x. This is the right derivative of f at x. So here I actually mark the point as x. So we just call that point x on the graph, and then f prime at x, f prime plus at x. This is what we call the right derivative. Now the right derivative is almost the same as the regular derivative, the two-sided, but we have t is approaching x plus. Or if you, in the h version, it's h approaching 0 plus. That's called the right derivative. So now what I'm going to do is I'm now going to get to the other file. I'm going to now have prepared another decimals, and then I type in some stuff in there. So now let's do this here. I'm going to now erase this, and so now let's look at this guy. The other decimals is right here. Oh, what is this? Let me unclick this guy. Oh yeah, this one. Okay, this one here. Let me first erase the words of tangent line. This one, let me unclick the tangent line. This is the curve. In fact, this curve is what? This curve is f of x equals x squared. When x is less than 1, it's x squared. And when x is bigger or equal to 1, this is minus x plus 2. Yeah, this curve right here is actually example 4. Example 4 looks like this. Okay, make sense? Let me unclick these, label. Let me unclick it. And let me unclick the label here too. So this is the graph of y equals x squared when x is less than 1, and y is equal to minus x plus 2 when x is greater than 1. This is actually example 4. And now the question is, what is the left derivative? Now, if you pick any other point here, let's say like this, let me see, let me pick a point here, A, like this, and then how about if I make this move, how about let's say take the point right here. At that point, if I click the tangent line, what does the tangent line look like? The tangent line looks like this. Oh, that is not the tangent line. What is the tangent line? Or what is H? Well, H is minus 7.5 here right now. So let me change this to what? Let me change this to where's the H? H is where's my H? Oh, H is right here. H. Let me change this to how about I'll make it 0.01. At that line right there. H is this guy. And the red line is actually the tangent line. But if you look at the tangent line here, the tangent line is actually what? It's actually two-sided tangent line. Whether we approach from the right or left, we get exactly the same thing. So in this case, let's say, how about if you let a is equal to, let's say, -1, you can say a equals -1. How about -1 here? And then now I'm going to make the h move around. You know what? What is this? This is the tangent line. Yeah, tangent line right there. Okay, there we go. So let me mark this point right here. There we go. Now here, what is the left tangent? Now let's try to find the left tangent. Let's try to find the right tangent. If you want to find the right tangent, what is the right tangent to the curve at x equals -1? Then we pick this point right here, -1 at x equals -1, and the other point is going to be on the left side. And then we now move this point along the curve and move this point towards that fixed point, and then that's what you see. So the slope of that one right there we see right here is this line right here is called the right tangent. This is a tangent line, but it's approaching the right side. But if you approach from the left side, what happens? Well, we end up getting the same line. This is the left tangent. Whether this point is on the right or the left doesn't really matter. Why is it? How come both of these colors are the same color? Why is it? A comma F way. And what is A comma F way?